Hello everyone, my name is Piotr Jabłoński and I'm a solutions architect at customer success at Isovalent at Cisco. Cisco acquired just a month ago a startup which is called Isovalent. Isovalent is a creator of Cilium, Tetragon, Hubble, open source projects, and these are muscles and observability for Kubernetes cloud native environments. I would like to focus on isolation, but Istio is just the example. Even if you don't use Istio, I think this presentation might be helpful for you because there is also talk about serverless and general perspective on the cloud native and how the isolation is critical to provide security not only on one level, but cross-level isolation is actually very important. I lost my hair in networking, security, and cloud for over 20 years in different various companies, Palo Alto Networks, VMware, Cisco. That's my second stage at Cisco. I spent 7 years already in the past. I participated in different various projects across market for service providers, for banks, etc. So I hope I can share with you some experiences. There is a small disclaimer, so again, Istio is just the example where I discovered particular weaknesses, but it doesn't mean Istio is worse or better than other solutions on the market. My intention here is just to give you an example again and make you aware that cross-level isolation is important nowadays. Also, every solution on the market has weaknesses. If you don't see weaknesses in your solution you like, maybe you haven't spent enough time with this solution. And AI is not so ever needed in any of kinds of isolation mechanism discussed today. Although machine learning can be utilized in the form of an advisory or engine which can help you to make a decision where to use specific configuration. I will jump straight to the demo and also discussion how the Istio architecture looks like, because this specific breach is exposed every half an hour. Every half an hour when the airbag policy is updated by zTunnel. So the last update was 14:52. There's 2 hours behind on this clock. So we can expect somewhere between 3:20, within, let's say, 5 minutes, 7 minutes, we should have a breach of this policy. So what is happening on these screens? In the right bottom corner, there is a continuous kernel which is trying to get the access, get the response from the server, specific server, which is not accessible according to the Istio enforcement policy. So if I break this for a moment, I will show you what is the command. So this is command curl to the server 10.244.1.6.90.80 port, TCP port. And I could use, of course, DNS, but I would like to make this not depending on the FQDN, not make it depending on the DNS name, just a pure IP connectivity. So on the top left corner, there is a different port which doesn't have the access either. I would like to give you the example that breaching this Istio enforcement policy is affecting the whole cluster. It's not just giving the access to the particular stream or particular pods which are trying to enforce or which are trying to use the DDoS attack, but actually all the pods in the cluster get the access to any pod existing in the cluster. At this moment, there is no connectivity. The enforcement policy is working correctly. Meantime, we are trying to breach. Why this security policy is enforced? Essentially, the architecture of Istio ambient mesh specifically, I will tell you more about this architecture shortly, is exposing control plane to the data plane pods. And this is quite significant weakness, which is not aware across the industry. So if you use Istio ambient mesh, that's fine, but please protect your control plane. Meaning Istio-D, Z-tunnel is a daemon set which is existing in the form of a proxy pod on each of the node, is exposed with its own IP address to any pod existing on this node, and even on the same cluster. You can reach this IP, which is control plane IP, which is IP belonging to Z-tunnel, to any pod existing in the cluster. Let's have a look on this IP. I wouldn't like to miss this opportunity to give you the live overview what is happening in the bottom right corner. But meantime, let's jump to the view, which can give us more hints how does the configuration look like. So, from the architecture standpoint, maybe a bigger screen might be helpful. This is the whole list of pods in this demo environment. And from the control plane perspective, in the Istio system namespace, we have essentially our control plane, which is responsible for this MTLS enforcement policy execution and updates and also spreading around and changes and updates. We have here in this demo 3 nodes in the cluster, so that's why we have also 3 Istio CNI node pods. CNI is responsible for discovery of new pods and preparing the pods in terms of connectivity. So when the Z-tunnel is authorizing specific pod for the communication, Istio CNI is preparing the socket in the specific application pod for the transmission, for the secured and encrypted transmission to the other node or even within the same node, because enforcement policy works also on the same node. Istio-D is a one control plane component which is responsible for authorizing Z-tunnel proxy to represent other pods and make authorization and authentication of all the pods against each other. And Z-tunnel is a proxy service which is equivalent to the sidecar, which you may know from standard Istio. So standard Istio is providing a sidecar for each pod. So each pod standard by default is having a sidecar in each pod separately. In ambient mesh, because this is ambient mesh, the philosophy is a bit different. The philosophy states that we have one proxy per node. What is the benefit? We have better performance because we can avoid too many sidecars, but we can also avoid situation that our secrets are exposed and compromised once the application container is compromised as well. Because within the same pod, all the containers are sharing the same volume and the same secrets and all the certificates. So when the pod is exposed and compromised, all secrets and certificates are compromised as well. So that's why proxy, putting this proxy aside to the node is giving us higher security, in fact. Meantime, yeah, we have break successful. What does it mean? What happened in meantime? So at 23 minutes, just 2 minutes ago, I will restart this test so we will have again the opportunity to observe the result. But just 2 minutes ago, there was an update of Z-tunnel zTunnel is updating airbag policy every half an hour, and this is the window of opportunity for DDoS to impact the service which is behind. What is exactly happening there it doesn't matter at this stage because it's fixed. If you use the newer version of Istio, it's fixed. But here, by using a standard DDoS attack or DOS attack, you can make a pressure on this proxy service to expose the flow. The flow which is giving the access to all pods, from all pods to all pods across the whole cluster. As a proof, we can go to back again to our previous top left corner pod and try again. Now the service is available. So what is the enforcement policy? Maybe enforcement policy does not work. Let's have a look. To get the access to the authorization policy or to authorization policies. Authorization, okay, let's try again. Security Istio system, nothing here. Okay, so authentication. Actually, right now, there is an interesting situation because authorization policy states there is nothing here. So let's apply authorization policy. Error server, that's the beauty of live demos. So what exactly we have? Operation can be, okay, that means that we have already authorization policy in place. So maybe my tool, which is K9, is actually not giving the right output. So let's use the native command, kubectl get authorization policies. Aha, yeah. We have authorization policy, OYAML. And this is the authorization policy. So we have action allow. From the source principle, two principles are allowed as a source. What is the meaning? Meaning is we are allowing with this policy from the cluster local, namespace default, service account sleep. So any pod with this specific service account in this specific default namespace can generate the traffic and it will be allowed. Other principle can exist in the same namespace, but service account is a book info. Essentially, we are trying to establish connectivity just to book info application in this cluster. Apart from that, we have match labels which are indicating the same product page application. So this is also the proof that the policy is actually breached, because the policy is in place, so our pods existing here shouldn't have the access, but still they have the access. Okay, so how to make this policy working back again? I can either restart the zTunnel or reapply the policy or do some changes in the configuration. I will simply delete the policy and reapply it again. So the same policy is existing back again in the system. And after reapplying the policy, you see the connection is broken. So again, policy works as expected. The airbag update is giving us the latest timestamp. Please note that this is clock 2 hours behind our current clock, which is 3:30 p.m. And the same pod, which is in the top left corner, should give us the result, which is visible here as a reset by peer, which is meaning, again, the enforcement policy works. So I can breach this policy again, because in the background, DOS attack is continuously undertaken. How this DOS attack looks like? How is it done? So if we move to the one of these containers, I have 2 containers which are doing the DOS attack here, and do ps-ef. These are commands using hping, flat, very standard commands utilizing half-open sessions, so sending flat traffic based on the TCP SYN, nothing else. Some UDP traffic, some ICMP flat. I found that sending just TCP flat, TCP SYN flat is not effective enough. If I'm sending flooding of the UDP and ICMP traffic, I'm stressing Z-tunnel much better in achieving even 100% effectiveness, because otherwise the effectiveness can be 50% or so. So what's the purpose of this exercise? The purpose of this exercise is, again, to show you that even a dummy pen tester, who I am at this moment, can, by utilizing a very basic knowledge in terms of pen testing and attacks, can explore the multi-tenant Kubernetes cluster and breach the security. Because the potential impact is quite huge. I'm doing this DOS attack from a standard-based pod. This pod is not having the security privileges. There is no host PID. There is no permissions which are over-permissive on the host. This is the standard pod. And from the standard pod, I can ping the control plane components in the Istio environment. So if I go to the view of all the components, I can grab one of the IPs which are existing, which are visible here, like 10.244.1.14, and just do the ping. And this is by design. This is by design. So, you know, Istio MTLS is a great tool to protect your TCP traffic, for sure. But please protect your foundations. Protect your operating system, harden this system. Standard Kubernetes does not provide you anti-spoofing mechanisms. Please use CNI, which is giving you anti-spoofing, which is giving you ability to filter ICMP traffic, which is not necessary for this communication, to Z-tunnel, which is able to filter out unnecessary traffic, which is UDP, because authorization policy is just for TCP traffic. So to better understand what I said in the demo, let's have a look on the picture, just to rephrase what we stated here. So in this picture, you can see the very brief and basic Istio ambient mesh architecture. So again, one Z-tunnel proxy is equivalent of typical sidecars which are installed in each of the pod, but instead of doing this, you can have just one zTunnel proxy per node. And this zTunnel proxy is protecting the traffic, meaning authorizing, authenticating pods against each other, plus encrypting the traffic in layer 4. Before doing that, zTunnel must authorize against Istio-D whether can represent the source or destination pod in the communication, because the communication is always between two entities. The Istio installation was a standard one. If you want to replicate it, yeah, I can give you the commands which are using as a DOS attack, but the installation is very, very standard from guides from istio.io. Based on version 1.20. I did this breach in December last year. Of course, I raised my hand to the security at Google, at Project Istio, so they of course, fixed this vulnerability, and you make no worry. Definitely 1.22 version of Istio is patched against this breach. Istio ambient mesh components, so we discussed this already. What is nice, if you install Istio, you don't need to restart application pods. And other test observations which I discovered based on this tests were the following. Also, there was a weakness which was related to established TCP connections. What does it mean? It means if you have established TCP connection and the policy has changed, disallowing the communication between these two endpoints could still communicate because the session was already established. So this is not a strong enforcement, but rather enforcement based on the newly established connections. This has been fixed. The first issue has been fixed. The second issue is by design. It's not going to be fixed. You need to be aware that UDP and ICMP traffic is simply allowed. Istio is not destined to protect you against this kind of traffic. And as you can assume, several different kinds of attacks can be performed using UDP and ICMP. And the third row is policy breach using TCP SYN flood attack. This is what I did and presented to you just seconds ago. This has been fixed as well. I tried also other tests. Not all of them are produced flaws or discovered weaknesses like IP pool relocation, changes of identities. Here, Istio played very good role, but please be aware that also zTunnel and Istio-D can be separately the destination of your potential attack from the outside of the cluster even. So two potential issues are by design, and this is the surface where you can apply additional isolation techniques like network policies in Kubernetes, like CNI. Depending on the CNI you are using, you can have anti-spoofing mechanism, which I mentioned. Two issues has been fixed. That's excellent. Additional observations I'm just giving you as an example for your reference. Please note that Istio, just one thing which I would like to comment is that if you really break the communication with the control plane, like with Istio-D or zTunnel, the whole Istio ambient mesh behaves like a fail-close solution. What does it mean, fail-close? It means that no authorization is possible, so no communication is possible. Do you like it or not? It is your decision. There are also solutions on the market with MTLS with fail, not open, but fail continue. What does it mean fail continue? It means that the recently pushed policies to the kernel or to the host-based solution, host-level solutions are executed. So last updates of policies are executed. This is the behavior of some solutions other than Istio. So you can choose whether do you prefer fail close or fail open. But please be careful with the architectures which are exposing control plane to the external attacks. So as a recommendation, before you focus on any sort of networking level solutions, measures, security, parameters, firewalls, please take care of the first portion of recommendations. What is the first portion? The first portion states, plan your identities. Plan how do you identify your applications, pods, virtual machines, whatever. If you don't use Kubernetes, it might be virtual machine. If you use public cloud, it might be serverless function. Different services, they must be identified in a proper way. Why? Because then we can provide separation of and proper isolation, quicker, faster, and more flawless. And introduce this security management to the DevOps, meaning if you have management of infrastructure in the pipeline as infrastructure as code, then you can split this pipeline into different segments where people from development, from DevSecOps, from security, InfoSec, and other guys can take their role and apply their recommendations. Especially this is important from the fact that nowadays even fully isolated Kubernetes clusters or other environments are also prone to attacks from the weakest link, who are humans, and also supply chain. So supply chain meaning the malware can get the access from the code. So that's why SaaS, Dust, and sandboxing is also important. Sandboxing, isolation form of behavioral testing of containers. But this is not the finish of the presentation. You can consider why using containers if using functions is much easier, isn't it? Functions are better protected. Is that true? Yes, no? Let's consider a shared responsibility model for serverless functions. Based on the AWS example, but it's applicable also to Azure and GCP. The demarcation line is very thin and suggests that you don't need to take care of networking infrastructure, execution environment, compute, runtime language, and other functions. Is that true? Not really. Why? Because in your layer, in the customer layer, you need to take care of TCP/IP functions, connectivity, DNS requests, API sockets, secrets data, metadata, privileges, IAM permissions, etc. A lot of other things as well. What does it mean? It means that you can be prone against specific vulnerabilities. We will jump to this topic shortly. But what I'm suggesting is to change the responsibility model to show that the responsibility of the customer is also related to networking infrastructure, runtime, execution environment, and compute. Even if you use just Lambda functions and that's it. Your data are existing on the compute level, which can be exposed easily to the internet. So this is giving you, give you some additional perspective what is possible with Lambda function. Let's answer these three questions, true or false. Lambda function, by default, a function is isolated from the internet. True or false? Who thinks this is true? Who thinks this is false? Why false? This is because this is presentation about breaching security policy. This is false because by default Lambda function is not associated with any VPC. So even if you have, I didn't mention about WAF, you have WAF enabled, excellent. But if your Lambda function by default is not associated with any VPC, you can exit AWS environment anytime. You can connect to any destination you want. No firewall is protecting your exit, no security group, no WAF whatsoever. Second question, a function can trigger a reverse shell. Can you establish a reverse shell to the Lambda function? Yes? No? You are shaky. True. You can establish reverse shell to the runtime engine where the Lambda function is running. That's the definite proof, unfortunately, that your serverless environment by default has to be revised. And the third question, file system and the content can be listed from outside. This is pretty simple if the second question is true, because the third question is also true. If you can establish the reverse shell, you can list the files and the content of your Lambda functions quite easily. When I tested this 2 years ago or 3 years ago, runtime for Lambda functions was not so well protected, hardened. Right now it's much better hardened, meaning you cannot explore the full file system on the underlying runtime system, micro-virtual machine. But even without it, you can still see the code of the Lambda functions or other files existing in the same file level structure. So if your malware or the malicious code is embedded into the Lambda function, you can guess what can happen. Someone can get the access to your environment, and if you give the privileges to other components in your serverless architecture, you are done. You can be explored fully by someone connecting from outside. So what you can do with that? Again, isolation. Isolation techniques for serverless functions. First of all, assign Lambda function or any function in any public cloud to a VPC or VNet. Because then you can control the traffic. Then WAF or firewall policy or security groups kick in. Please note, though, that by default, again, by default, DNS requests are going sideways, are not going the same path as the IP TCP traffic. It's served sideways. So that's why you need to take care also separately of DNS requests in the public cloud. But at least you can build some perimeters, isolation perimeters. And at the end of the day, please remember also and keep in mind that you need to have a proper IAM privileges, permissions between services. But this is quite obvious. What is not quite obvious is this fact, that Lambda function by default is not within VPC. So, of course, this session will not deplete all the examples we can give in the combination of virtual machines, containers, Lambda functions, etc. But at least you need to think laterally, cross-architecture, multi-level. If you are specializing in layer 7, please look at the other layers. If you are a developer, please look at the other layers. This is important to provide isolation. And more general content at the end, because this is, for some of you it might be obvious, so this is optional content for today. We have 10 minutes left, so I will use and discuss this right now. So the part of this presentation, there are two components, major components of this presentation, isolation and cloud native. And to provide good isolation, we need to understand what are characteristics of cloud native. So I listed some of them here, and which is quite frequently omitted is the bottom line, job 0. Always prepare your identity or RBAC, role-based access control, properly. What does it mean properly? It means have a policy to give the tags, to assign tags or identities in a proper way. What does it mean proper way? It means that you know that application A will have the labels A, B, C, but application B will have labels Z, X, Y, Z, and they will not interfere at any moment by perplexing labels at any point by different departments. That's the separation of duties, that's the separation of departments and isolation at the organization level, which is also important. So apart from focusing on the isolation on the networking level, we need to keep in mind of isolation at the organization level. As an interesting fact, if you think that cloud native is just a matter of containers or Lambda functions, what connects Toyota RAV4 with hacking of distributed systems? Maybe you heard, maybe not, but you can break the headlight in front of the car, which is the fairly weakest physical protection, and get the cables. You can connect your computer or programmer and get the access to the shared communication bus inside the car. From there, as you can suspect, you can you can open the door of the car, and either from the inside or again from outside through the gateway, you can bridge the gateway and get the access to the engine control and ignite the engine. Luckily, there is no steering wheel yet in this architecture, but we can suppose it's also a viable solution that you are sitting in the front of the computer somewhere in the sofa, in the cautious luxury place, and you are driving the stolen car. Hopefully, it won't happen. So this distributed system is very similar, alike to the system of cloud native. We have 3 stages of the attack, and the same can happen with a standard container-based solution. So this is the example. The link on the right-hand side is the presentation which I gave about revealing blind spots in the Kubernetes cluster using observability tool. This is another topic, but also important, because observability is making you aware where the isolation is, where isolation is needed. Here, what happened in this demo, with the link I provided on the right-hand side, what happened? Malicious code through the Log4j vulnerability get the access to the yellow pod, and the yellow pod initialized automatically reverse shell to the external pod for further exploration from this external red pod. What is the next step? In the next step, there is the escalation attack between these yellow pods to the phase, which is phase number P3, privilege escalation, where we get the access to the host level, because we can, as you know, there are techniques to escape from the container to the host level, and you can get the access to the host from where you can instantiate or do anything you want. Of course, someone can say, my operating systems are hardened enough. Excellent, but developer clusters are not so hardened enough. And isolation between the production systems and developer systems might be not enough. So my suggestion is, please check if the lateral movement is not really possible. If it's possible, then from the hardened system, on layer 7, you can jump across different virtual machines or different containers, because this is the typical architecture or layers in the virtualization stack where you have containers. You have containers on top within the virtual machine, which is standing on the hypervisor or on the bare metal operating system. And typically, escaping from the container to the virtual machine is much easier than from virtual machine to hypervisor or between virtual machines. But escaping on the application layer between the containers is much easier than escaping or moving laterally between virtual machines. So if your application is prone to attack or vulnerable at layer 7, possibly the malware can be spread at layer 7. And even if there is no container escape to the virtual machine, and virtual machine is not exploited, still the weakest or the most crucial thing in this whole architecture is your data. It's not your infrastructure, it's data. If you lose data, if the data is compromised, is overheard, is lost, it's stolen, this is the most precious thing for your company. So that's why layer 7 today is important to protect with distributed WAFs, with distributed protection mechanisms spread across these functions. And the last comment from my side is, if you can provide your isolation techniques or security perimeters as close to the application as possible, that's a better approach you can use versus security perimeters standing in front of somewhere, standing in the one point of perimeter, bench, fence, somewhere in the environment, because you don't know, you don't have control, full control of what is happening in the cluster. So that's why for distributed systems, I'm recommending using distributed security solutions. It's not always possible. Sometimes there is a performance penalty. Sometimes there is a maybe a higher cost. Yeah, that's fine. We need to judge what is the proper investment level against the risk and against the loss of this property. So just a summary, what are the levels of boundaries and isolations we can achieve, weak, medium, and strong. That's why public cloud providers are running functions not in the containers alone and containers directly on the bare metal, but they are inserting always containers within virtual machines as an additional level of isolation. Recommendations again, if there are any comments, I'm happy to answer any questions. We have just 2 minutes more, so thank you for attending this last session.